So this is section 3.3, properties of functions, and today we're going to do objective 1, which is using a graph to determine where a function is increasing, decreasing, or staying constant, and we're going to learn what it means for a function to be even or odd. Function can also be neither. Turns out those two words correspond to a lesson earlier when we learned about symmetric with respect to the y-axis and symmetry with respect to the origin. We'll get to that. Okay, so first let's go over the first concept about increasing, decreasing, or constant. So here's the concept. What does it mean for a function to be increasing? Well, as a graph, it basically looks like this. It would look something like, going up, or maybe, going up steep like that. Basically, it means as x increases, y increases. So it means that it's leaning that way. Okay? What does it mean for a function to be decreasing? It's the opposite. As x is going up, y is going down. And so the way that would look is maybe like that, or straight, like that. That's what it means to be decreasing. What does it mean for a function to be constant? It means it's going to stay level. That's supposed to be horizontal, okay? Now we're on the first example. So determine whether the function is increasing, decreasing, or constant on the interval from -2 to -1. So you have to find that interval. This is x, okay? So this is -2 up to -1. So when you look, it's looking like the graph is increasing. So that's all you do. So you say it's increasing. Okay, that's the end of that example. You'll see that in the homework. Next problem. Find the intervals on which the following function is increasing, decreasing, or constant. So we got to look at this whole graph and see, okay, is it ever increasing and is it ever decreasing? Is there an interval where it stays constant? Well, let's take a look. If you notice to the left of x equals 0, the function's going up, so it's increasing. And then as x goes beyond 0, it's decreasing. So there's two answers, and so this is what we're going to say. It's increasing on, I should say on, negative infinity, x equals negative infinity, up to 0. It's going up, y is going up. And then it's decreasing on, we pick up from there, 0 to infinity. It's never staying constant, it's never level anywhere. Okay, so that's the end of example 2. On to the last concept. What does it mean to be even graphically, and what does it mean for it to be odd? Okay, it turns out even means it has to be symmetric with respect to the y-axis. Okay? What does it mean for it to be odd? It needs to be symmetric with respect to the origin. Now I need to go over, I think it's been a while for you, what that means. Okay, so again, the y-axis I think, is really easy if you think like, oh, here's x, here's y, here's the y-axis. So to be symmetric with respect to the y-axis, it would mean if I fold this graph along the y-axis, it hits. So that's what it means to be even. Okay? What does it mean to be odd? And so what does symmetry with respect to the origin means? It means this, that if I have a graph, say something like that, and I pick a value x equals so-and-so, and then I pick x equals the negative of what it was over there, then the distance from that point to the origin and that point to the origin will be the same. That's called odd. Okay, so let's go over this. For the following functions, there's one there and one there, say whether they are even, odd, or neither. Okay, well, this one's odd, because if you pick this and this, the same distance to the origin. Okay, that's x equals 2, that's x equals -2, and so on. It's symmetric with respect to the origin, it's odd. This one is neither, it has no symmetry. It's neither even nor odd. Okay, so that's it for this exercise.